We know that the PDCCH is transmitted inside a CORESET, but a CORESET can contain many control channel elements. So, how does the UE know which control channel element actually carries its DCI? Does it decode every CCE, or is there a smarter way? Imagine if the UE had to decode every control channel element inside the CORESET. Most of the CCEs belong to other users. With this method, UE would waste processing power and battery energy. Clearly, this is not an efficient way. Instead of decoding every control channel element, now the network tells the UE exactly where it would search. These selected control channel elements form the search space. Now the UE monitors only these locations and safely ignores everything else. Some control messages must be received by every UE. During initial access, every UE needs to receive the scheduling information for SAB1. These shared control messages are transmitted through the common search space. So, every UE knows exactly where to search. After the UE enters connected mode, now the network configures a dedicated search space for each UE. Now each UE monitors its own search space, instead of monitoring every possible location. Even inside a search space, UE does not monitor continuously. Instead, it wakes up only during predefined monitoring occasions. At each monitoring occasion, receiver wakes up and checks for the DCI and then returns to sleep mode if nothing is found. Monitoring occasions repeat with a specific periodicity. Some search spaces are monitored every slot, and some are every 2 slots, and some are every 4 slots. This monitoring periodicity determines how often the UE wakes up to search for the control information. Within a search space, there can be multiple possible PDCCH locations. These are called search candidates. Now the UE checks the candidates one by one until it successfully decodes a valid DCI message. UE still does not know which search candidate contains its DCI. It therefore performs blind decoding. UE starts decoding one candidate at a time and checks its CRC. If CRC fails, it immediately moves to the next candidate. This process continues until its valid DCI is found. This entire process is called blind decoding. Here UE is not guessing the information. It simply checks each candidate until one passes the CRC. UE first monitors its configured CORESET and search space. When monitoring occasion arrives, UE starts checking the available search candidates. Each search candidate is blind decoded and its CRC is verified. As soon as one candidate passes the CRC check, UE successfully decodes the DCI. Now the DCI tells the UE exactly where its PDCCH is located.